In part 2 of this lesson, where we use the chain rule with partial derivatives, we ended off with the question shown on your screen where we have to find the partial derivative of this function with respect to t. Now notice that our function consists of 4 different variables, u, v, w, and x. So what you do is write down f and your 4 variables, u, v, w, and x. And we have 4 separate equations that are in terms of these variables, and they're all in terms of s and t. So we'll write down st for each. We're creating a tree essentially to see how we can find the partial derivative using the chain rule. So they want the partial derivative of the function with respect to t. So we're going to find the partial derivative with respect to u and then t, the partial derivative with respect to v and t, w and t, and lastly x and t. Once we find all of those, we will then multiply them by the derivative of each of those equations with respect to t and sum them all up. So let's get started. We have the partial derivative of our function with respect to t is equal to, starting with this term, we have u x to the power of 2. If we take the partial derivative with respect to u, x squared is a constant. Here, in this term, we have no u, so it becomes 0, it's just a constant, and treat this as a constant as well, no u. Now we will multiply this by the derivative of this function with respect to t. That's a constant, 3s, and here we have 2t. Using the power rule, that becomes simply 2. So we multiply this factor with the derivative 2. And in case you're confused about what we just did, we found the partial derivative of our function with respect to u, and then we multiplied it by the derivative of the equation u with respect to t. So here, this becomes 2x squared. Now we have to do this for v. So the partial derivative of our function with respect to v, and then the derivative of v with respect to t. Let's go ahead and do that. Starting with this term, there is no v, so we don't have to worry about that. We don't have to worry about it here either. And over here it becomes negative 3v squared. Now we multiply by the derivative of this equation with respect to t, and that's simply 5. So this becomes negative 15v squared. Now, the partial derivative of our function with respect to w. And then we'll multiply dw and the derivative of that with respect to t. So starting here, no w, that's good. Over here we have ewx, and the derivative of wx is x. Because x is a constant, and using the power rule, w goes away. That becomes 0 as well, and we multiply that by the derivative of this with respect to t is 2ts. Easy. Now last one. The partial derivative of our function with respect to x, dx over dt. Let's go ahead and do that. Starting here, we have 2xu. Over here we have plus ewx. Multiply that by w, and this becomes 0. And we'll multiply that now by the derivative of this with respect to t is negative 1. Let's clean this up. We have 2x squared minus 15v squared plus 2tsxewx minus 2xu, and we're multiplying this negative 1 to this term as well, so negative ewx times w. Of course, you now have to replace all of those letters with what they're actually equal to. So where you see an x, you will replace it with negative s minus t. And if you do this correctly, you should end up with the following expression. So what you see on your screen is the partial derivative of f with respect to t. And there you have it. That is how to use the chain rule with partial derivatives.